Hello, in this video I'm going to solve the following diamond level problem, one variable calculus, topic definite integrals. This is a problem from Vietnam. Let f be a positive function defined on the closed interval 0 to 2 such that f of 0 equals 1. If f is differentiable on the closed interval 0 to 2 and f of x times f of 2 minus x equals to e to the power of 2x squared minus 4x for all x in the interval from 0 to 2, then this integral that you see on the display now is equal to, pause the video at this point and give it a try to see which one of the given following options is the correct answer to the problem. Okay, so let us solve the problem here. So I know that the function is positive on this closed interval. What does it mean? It means that if I choose any number from this interval and calculate f at that number, the output is a positive number. So that is the meaning of a function being positive. And of course, they have mentioned that f calculated at 0 is exactly 1. And if you choose any x from this interval, f of x times f of 2 minus x is equal to this one. And we know that f is differentiable on this interval. Of course, if the person who designs the question, they have to be careful about 2 minus x, because we know that the function f is defined on the closed interval 0 and 2, but that is not a big problem, because if x is somewhere between 0 and 2, if I multiply this by minus sign, then it becomes minus 2 less than or equal to minus x less than or equal to 0. And if I add 2 to all sides, this becomes 0 less than or 2 minus x less than or equal to 2. So this means that 2 minus x is also within the same interval. So no problems here. Okay, but how should I start thinking about the problem? The way that I did it is I realized this combination f prime of x over f of x is a very famous combination in calculus, yes? So I know immediately that ln of absolute value of f of x, the derivative of this function, whatever f is, as soon as f of x is not 0, it becomes f prime of x over f of x. Okay, and I do not have any problems here because it has mentioned that f of x is positive and differentiable. So the denominator cannot vanish, and of course f prime of x exists because it is differentiable. Another thing is that I do not need this absolute value sign because f of x is positive, so absolute value of f and f, they are the same things. Okay. So it seems relevant, yes, because first of all, this combination you see in your question mark, and it is related to the derivative of ln of x, ln of f of x, and then it means that somehow I have to use this, if my understanding is correct, and it is close to the desire or intention of the designer of the problem. Okay, but here the information provided for me is without ln, but I need an information regarding ln of my function. That is not a big problem. It motivates me to take ln from both sides, yes? But ln of this expression, this is a product. ln of a product can be written as ln of the first one plus ln of the second one. And ln of the second one does not have any problems because of the same reason I mentioned here. 2 minus x is also within the same interval, and that function for any number in that interval is positive, so neither this ln is problematic nor that ln. But if I take ln from this expression, this will go to the back of ln, and ln of e remains, but ln of e is just 1. So it becomes 2x squared minus 4x. Okay, so I am one step closer to my desire, yes? At least ln of f of x appears from that relation. That is not good enough because I need this combination, so this motivates me to differentiate this from both sides so that immediately this combination that I see in my question mark appears. It's reasonable. I am not saying that this guarantees my strategy is correct, but this is the way I thought for the first time when I saw the problem. So I differentiate both sides, so this becomes simply f prime, or let me write it in front of it. Oh yeah, let's continue. So this becomes f prime of x over f of x plus, but you have to be a little bit careful here, ln of a function. If I want to differentiate it, the function goes to the denominator, but I have to differentiate it and put it in the numerator. But be careful here, don't put prime here. You have to differentiate the whole package. On the right hand side, differentiation is extremely simple. It's just 4x minus 4. Why I told you have to be careful? Because if you want to flip this prime from here to here, there is a price to pay. The price is to multiply by the derivative of the inner function, because this is the chain rule. So if I go one step further, f prime, I copy and paste the first fraction. I copy and paste this one. I copy and paste the denominator. Yes, copy paste the right hand side. There are nothing I can do here. But now my goal is to flip the primes inside. So I have to use the chain rule. So the chain rule will tell me you can do that, but there is a price to pay. And the price is multiply everything by the derivative of the inner function, which is minus 1, so it will change the plus sign to minus. Okay. What is the next reasonable step? The next reasonable step is that I want to construct this combination. So far, I have this combination here. Okay. So it motivates me to multiply, to make this expression appearing here. But of course, I cannot just make it here. So the first thing comes to mind is to multiply everything by that expression, that polynomial, okay? So x to the power of 3 minus 3x squared, I multiply it by f prime of x over f of x. I also multiply this one, x to the power of 3 minus 3x squared. Then I multiply it by f prime of 2 minus x divided by f of 2 minus x. And then on the right side, I should also multiply it by x to the power of 3, 3x squared, multiplied by 4x minus 4. Okay, but my goal is to calculate the integral of this expression. Again, it motivates me to take integral, yes? If this function is equal to that function, integral of this function is also equal to integral of that function. But here I can separate my integral to this one minus that one. So if you don't mind, I'm a little bit lazy. Let me just now put the integrals here. I have to put a dx, of course, here, minus the integral here from 0 to 2. I have to put a dx here as well, equals to integral from 0 to 2. I have to put a 2 dx here. Okay, let us evaluate what we have done. Is it promising or not? Okay, this one, no problems, because that is exactly my question mark. So this is the unknown I am looking for. What about the right-hand side? No problems at all. At the end, I just multiply them. It becomes a simple polynomial, and this is an extremely elementary integral to calculate. So that is also good. But the problem is that this is apparently a new integral, okay? Okay, so in principle, I should call this integral j. But is there something I can do about j? J in 4 is very similar to my unknown I. The only problem is that instead of having x, I have 2 minus x. The people who have worked on integrals a lot, they immediately realize there is a theorem they can use here. And of course, they have to rely on the chance, because you have to think in this way. Is it exactly the intention of the designer of the question? Okay, that I can use this, because 2 minus x, what is this 2? 2 is the sum of these two. So this is 0 plus 2 minus x. So this immediately reminds you of this theorem, that integral from a to b of an integrable function like g of x dx can be always written as integral from a to b again, but g of a plus b minus x dx. I don't want to prove this because that's a very famous theorem in definite integrals, but I want to use it. But it is not still guaranteed that the designer has used this theorem. The only hint I got when I was solving the problem is comparing 2 minus x and seeing that this 2 is indeed 0 plus 2. Okay? 2 minus x is 0 plus 2 minus x, and it reminded me of this theorem that might be that was the intention of the designer of the question. Okay, so let me give this function the name g of x and see if that is true. So I will say that let us take g of x. I am explaining it in a very extensive way. You really don't need to do it in the pressure of time. You can just convince yourself immediately. So I will write this function to be x to the power of 3x squared, and then I have f prime of 2 minus x divided by f2 minus x. Do you agree? Let us say that this is your g of x. And let me calculate g of a plus b. A in this problem is 0, b is 2, so a plus b becomes something just 2 minus x. I'm calculating this part to see is there any kind of relation I can find. So what does it mean? It means that go to your function g, replace every x in your function with this combination 2 minus x. So instead of this x, I have to put 2 minus x but cubed, minus 3 instead of this x, I put 2 minus x squared, and then instead of this x, I put 2 minus x, but what happens? It is 2 minus x, which is just simply x. So this becomes f prime of x divided, for the same reason, this also becomes f of x. So good. It means g of 2 minus x has something to do with this combination, but now my problem is here. The only thing that I can hope for is somehow this relates itself back to the old polynomial x to the power of 3 minus 3x squared. But I think it is worth to check it out. To check it out, if you don't mind to simplify this, I can raise it to power 3, but I prefer to factor 2 minus x to power 2 out to see what it goes. And then from here, 2 minus x is left, and from there, minus 3 is left. So it becomes minus x minus 1. Okay? And then, of course, I repeat that last part, f prime of x over f of x. But let us see what happens here. I have to open it up. Okay? So this one is 4 minus 4x plus x squared, and this is minus x minus 1. If I multiply this, it becomes minus 4x minus 4. This becomes plus 4x squared plus 4x. And this becomes minus x cubed minus x squared. Yes, can I simplify it more? So let me write minus x cubed first. I considered that. And then minus 4x here and 4x there are gone. And then x squared, this becomes positive 3x squared. Good. And then I have a minus 4 left. And here, because my intention is to make this combination appears, so I am lucky. Between these two, I factor a minus sign out. And then, if you don't mind, let's keep minus 4 there. Okay, so now bottom line is what? Bottom line is that g of 2 minus x is indeed equal to this combination, which can be written in this form. Minus 4, but multiplied by that combination. Yes, f prime of x over f of x. And if you don't mind, let me open it. So this becomes minus x to the power of 3 minus 3x squared times f prime of x over f of x minus 4 times that. Okay, so this is g of 2 minus x. So what does it mean? It means that this integral, okay, j, is equal to, this integral is the integral from 0 to 2. I called this part g of x, do you remember? Dx. But according to that theorem up there, so let us show, according to this theorem, this can be written as integral from 0 to 2 g of 2 minus x dx, yes. But I was able to calculate g of 2 minus x to be this combination. So let us go forward. It becomes integral from 0 to 2. Instead of g of 2 minus x, I put this expression. So I break my integral into two parts. Integral of this one minus that one. This minus sign goes out, and it becomes x to the power of 3, 3x squared, f prime of x, f of x, d of x, and then minus 4 integral f prime of x over f of x, d of x from 0 to 2. Yes? So let me make everything clear. So this is the theorem up there I used. Instead of g of 2 minus x, I already calculated that here. So the integral of this will be the integral of this one, which I have written here, minus 4 times the integral of that one. But isn't it very beautiful? You see what happens, this combination without the minus sign, this part is your original unknown integral I. So this means the integral j that I was looking for is equal to minus I plus this, minus that integral, minus 4 this integral. But this is also very famous because if you take this u, the numerator becomes du, so this is nothing except ln of f of x. So this becomes minus ln of f of x. But I have to run it from 0 to 2. So what does this mean? This means that j is equal to minus I minus 4 ln of f of 2. I have to replace x with 2 minus ln of f of 0. But can I calculate these things? Of course I can. Because f of 0 is given directly in the problem to be 1. So f of 0 is 1, so ln of 1 is 0, so this will go away. But what about f of 2? F of 2 can also be calculated because this relation holds for every choice within this interval, including if I choose x to be 2. So if I choose x to be 2, this will be f of 2 times f of, if I choose x to be 2, f of 0 equals to, if I choose x to be 2, this becomes 8 minus 8, 0, e to power 0 is 1. But f of 0 is directly given to be 1. So this means that f of 2 is also 1. So what happens? This means that this is also 0. So very interesting result. Isn't it? Very beautiful problem. Very beautiful. So this means that j is equal to minus I. Okay. So let us now finish the problem. This is the question mark I. And now you see how minus sign here is extremely important. If you miss that minus sign when differentiating coming here, you will be in trouble. Because there is a minus sign here. And what is j? J is not I, j is minus I. So you see how that minus sign is crucial. And then what do I have? I have the right hand side. Then unfortunately I have to do this boring part. What I will do, I will multiply that polynomial in. So this becomes 0 to 2. Let us multiply. X cubed times that is 4x to the power of 4. X cubed dot minus 4x cubed. And then this one multiplied that is minus 12x cubed. And this one multiplied by that is plus 12x squared. And everything dx. Let me double check. So x 4x, yes, yes. And of course this part can be combined as minus 16x cubed. But the left hand side now becomes 2 times my unknown, and this is extremely easy to calculate. So this is 4 over 5x to power 5. And this is minus 4x to power 4 because a primitive function of x to the power of 3 is x to the power of 4 divided by 4. 4 and 16 will be simplified. And finally, this becomes 4x cubed. But I have to run it from 0 to 2. Yes? Okay, so 2i becomes equal to, I replace x with 2. 32 times that is 128 over 5. 16 times 4 minus 64 plus 832. So it's 128 over 5. And then what happens here is minus 32. So if I take the common denominator, 128 minus 160. So the answer will be minus 32 over 5. Oh, okay. Be careful. This is 2i. So I want to find I. It becomes minus 16 over 5. So that is the correct answer to the problem. Yes? So if I go back here, do we have this in the options? Oh, both of them were in the options, so be careful. This one is not the correct one. Part B is the correct one. Okay. So, yeah, that was a good, very nice problem. I really enjoyed solving it myself. You can also give me some comments if you have a better solution for it. Of course, you see, I explained a lot. You can really, if you're experienced in these kinds of exercises and exams, of course, you have to prepare yourself well enough to be able to do many of these calculations in your head. And it is indeed possible. It's not a big problem. But I was thinking that might be there is another alternative to this problem. I'm not sure if that is simpler or not. That is a vague idea, but if you don't mind, let us give it a try. What is that one? So I need to remember, so let me clean this part. Let us see how it will work. Because this combination, as I told you, it reminds me of this derivative. So might be the method of integration by parts should also work. Okay, I'm more or less sure that it will work, but I'm not sure if it is simpler or longer than this method. Okay, so let us give it a try. At least there is nothing we lose. We just learn more. Okay, so let us go back to my integral. So, but write it in this form. Integral from 0 to 2, x to the power 3 minus 3x squared. And then let me write this combination f prime of x over f of x d of x. Okay, might be there are some pieces of information that I will use from the previous method. Let us see how it goes. So if you are familiar with the method of integration by parts, you know that if you have integral from u dv from a to b, you can write it as uv and run it from a to b minus v du, the other way around, yes, from a to b. This is the very famous formula for the integration by parts. Okay, now I want to give the role of u to this one, and I want to give the role of dv here. Again, this will help me to understand that it might be a good idea to give the role of dv to that expression. If u is equal to x cubed minus 3x squared, I need du as well, so it motivates me to calculate du. The derivative of this expression is 3x squared minus 6x dx. And if this one is dv, one possible expression for v is just ln of absolute value of f of x, but I don't need absolute value here. So then I use the formula of integration by parts. So my integral I is u dv. According to the formula, it becomes uv. U is this guy, v is this guy. But I have to run it from 0 to 2 minus integral v du. This is my du and this is my v. So this becomes 3x squared minus 6 ln of f of x, and then I have dx, and then I run it from 0 to 2. Okay, I hope that you agree with me. This is again 0 because we just learned in the previous method that f of 2 is 1, ln of 1 is 0, f of 0 is given to be 1, so that's also 0. So this term vanishes. Okay? So what is left for me? So I will have I equals to minus integral from 0 to 2, 3x squared minus 6x, and then I have ln of f of x dx. Oh, sorry, dx. So I was able to show by method of integration by parts that this integral is indeed what I am looking for. So that integral can be written in this form. Okay. Okay, so then what can I do? Is there something we can do here? Let me see. Okay, so what do you think we can do? We were able to show that that question mark can be written in this form. What I haven't used so far is the important assumption up there, yes? I think more or less it goes back to the same thing, because now I see that I need ln of f of x, so it motivates me to take ln here. So what happens? So, okay, might be we don't need differentiations. Let us see. So from that relation, do you remember in the previous method we had this? So I don't want to explain it that much here now. So it was 2x squared minus 4x. Okay. So now ln of f of x, I want it from here, from this combination. So what I can do, so I can say that integral I that I am looking for, it has a minus sign, integral from 0 to 2, and then I copy and paste 3x squared minus 6x, and then instead of ln of x, I put this expression, 2x squared minus 4x, minus ln of that expression. I think, I don't know, might be this is even simpler. Okay? Okay, so, sorry, this is f. F of 2 minus 6. Okay, then what I will do, I will continue. I will multiply this by this. I will multiply this polynomial by this. So, but there's a minus sign here, be careful. So it becomes minus from 0 to 2, 3x squared minus 6x multiplied by 2x squared minus 4x dx. And then a minus sign here, a minus sign there, so it becomes plus integral from 0 to 2, 3x squared minus 6x, and then multiplied by ln of f of 2 minus x dx. Again, this is elementary calculation. We can do it. The problem is that can I somehow relate this integral to my original integral I? I hope that you remember the trick. So let us do that. I hope that this will work. So I can copy and paste the same interval. So I want to use the same theorem here, but for this integral. So I have to replace x with 2 minus x everywhere. So this becomes 3, 2 minus x to power 2, minus 6, 2 minus x, yes? And then everything multiplied by ln of f of x, and then dx. Okay, so then what can I do? Here I can factor a little bit out. So 0 to 2, I factor a 3 and a 2 minus x out. From here 2 minus x is left, and from here minus 2 is left. And then I copy and paste ln of f of x dx. Yes, are you with me? So I'm just following, I'm factoring 3, 2 minus x out, 2 minus x is left, from here minus 2. Okay, so then what happens, this 2 and that 2 are gone. This minus sign, I use it to interchange these two. I can pull 3 out. So this becomes 3 integral from 0 to 2. This becomes x minus 2 times x. Yes? So ln of f of x dx. Okay, so let me double check that I have done everything right. Yes, because yes, this is correct. So it will appear there, because I think I am a little bit in trouble. Then I will multiply this expression, 3x squared minus 6x, by that. Yes, this is correct. And then that one will also come here. But then I replaced x with 2 minus x everywhere. So it seems to be correct. Okay, so I factored a 3 and a 2 minus x out. Okay, now that's correct. I factored this out. From here, 2 minus x is left. From here, minus 2 is left. Okay, and then I get this expression. So apparently I haven't done something wrong so far. But I want to somehow go back to my integral. Okay. So do you see how can I go back to that? Here, if I multiply that, yes, that is exactly what I need. I'm not confused. Sorry. This is exactly integral from 0 to 2, 3x squared. If you multiply 3x in, minus 6x. Very good. I would say that this is also a good way to do the problem. Do you agree? Yes. So that is exactly what I need. So what I have now, I, which is this integral, okay, is equal to this integral. So if you don't mind, let me call this one m, for example. So minus m, and then plus this integral that I was able to convince myself is again minus I, because I is with the minus sign, but I do not have any minus sign here, so that is minus I. Are you with me? Yes. So I think this is also a good way to do the problem, to be honest. So what happens, I move minus I to the other side, so it becomes 2I equals to minus m. Okay, so if I calculate this m and then multiply by minus sign and divide by 2, I probably will get the same answer. Let us try it out, okay? It's a little bit exciting moment. So what I will do, I want to calculate this, but I have to open it up. So this becomes integral from 0 to 2. This times that is 6x to the power of 4. This times that is minus 12x cubed. Minus 12x cubed is minus 24x cubed. And this one times that one is plus 24x squared, and then I have dx. Okay? But if I want to calculate this, this becomes 6 over 5x to power 5 minus 6x to power 4 plus 8x to power 3. I have to run it from 0 to 2. If I put 2 here, 32 times that, 180, 192 over 5. Am I right? 32 times 6, yes. And this one, 16 minus 96. And this one, 864. So it becomes 192 over 5 minus 32. So this becomes what? 32 over 5. So this is your m. Be careful. This is the calculation of m. So from here, minus 32. So that's correct. So minus 32 over 5. So again, I is minus 16 over 5. Yes. So we will also be able to solve this problem using the method of integration by parts. So mostly the ideas were more or less the same. But in one of them, I started from my integral using integration by parts. And you see that I more or less use the same tricks. But in the former one, I didn't use integration by parts. I used differentiation. Anyway, that is good that we solved the same problem in two different ways and got the same answer. So this is somehow an indication that the likelihood that we are on the wrong track is close to 0. Okay, anyway, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you very much.